Hello, everybody. Welcome to another monthly stream. This is our Dylibso Insider Series. We're really excited for this one in particular. My excitement levels are off the charts, in fact. We get to kind of talk about something we've been working on for a good chunk of this year. Whether you're joining us in from X or LinkedIn or Twitch or YouTube, thank you for being here. We're excited to show you XTP for the first time, giving folks a demonstration of our next generation software extensibility infrastructure. Ben, thanks for joining.
Thanks. You can hear me okay?
Yeah, doing great. Just want to give a shout out to the whole team at Dylibso. Ben and I are lucky that we get to demonstrate this today, but it's really been an incredible effort and lift for the entire team at Dylibso getting this to where it is today. So thank you everybody for your hard work, and a special thanks out to our design partners and early customers and community for giving us the feedback we've needed to get to this point. So with that, I'm just going to kick it off. Just for our agenda today, we're going to talk about what software extensibility is, and kind of go over what the current state of the art is, who's kind of pushing the envelope in what's possible with software extensibility, and how can you benefit from these kind of new patterns if you're not a multi-billion-dollar company with a huge R&D budget. I'll try to keep this to about 15 minutes or less, just kind of rip through the introduction to all this stuff so we can get to the meat of this, which is a demo, and kind of live demonstrate what you can do with XTP and how easy it is to integrate into your applications. So let's talk about software extensibility. This is what we all kind of are familiar with in terms of a pattern of extensibility. You may have an API that your customers interact with your app with. You may have a webhook system to send some initial notifications. But ultimately, you've got two systems. Maybe it's your and a customer system, and they need to interact somehow. And so we're using kind of a isolated network to talk messages over. And system A may send a notification over a webhook to system B. It needs to be aware of some event that happened in the source of record, source of truth. And system A is going to say, great, I got an event, but I need some more data. And so it's going to ping pong back and forth as more data is necessary to ultimately complete this computation to make a decision about what to do inside of system B. This is going to span dozens of HTTP endpoints, moving lots and lots of data over the internet. We use this today because it's what's available, but it's got a lot of disadvantages. And that's where we think this kind of new world of software extensibility is moving. Some of these disadvantages are about like sending messages over the public internet. I might have two instances that are completely geographically distant. I might be on the other side of the world from the system I'm talking to. So your speed is bottlenecked by the network. You've got TLS and you've got retries and application off, all kind of getting in the way of computing a decision between two systems, which means the number of the interactions between these two systems, the back and forth between taking data in, calling some function, making a decision is severely limited. It could take seconds to do a whole interaction between two systems. The other disadvantage is that data is actually moving from your system of record into a subsystem, into maybe a completely different instance. And that subsystem is not in your control. You don't have any idea of how a customer is using your data. If they are vulnerable in a way you don't predict, they're exploited, where's your data going? Who has access to it now? It also adds some data residency concerns. Which jurisdiction is your data landing in? Is it even legal to have that data inside that jurisdiction? There's lots of complicated disadvantages here. And then the last thing is that these simple applications, what started with maybe a SaaS app that runs, now becomes a very complex distributed system where data is spread across a bunch of different systems, and the retry logic necessary and the acknowledgement of a webhook start to become more complicated than you may have originally thought. So that's what we're trying to focus on. Like, what is software extensibility 2.0, and how can we take advantage of some new technology to unlock capabilities that just really weren't possible before? So I'm gonna try to paint a picture here for you to talk about what this 2.0 world looks like. And I'm gonna use an example of a platform I'm sure we're all familiar with, the popular credit card processing platform Stripe. And they have a customer who's a merchant who's using Stripe to process payments on their behalf. And just like in the software 1.0 world, Stripe would maybe send a webhook when a credit card is processed to Acme Corp, the merchant, and say, hey, we have a new charge. What do you want to do? And instead, if Stripe could actually just take Acme Corp's decision, their code, and run it locally when that charge happens, what you could see is a usage pattern where Acme Corp ships some code that says, hey, when I get a credit card process, I want to get some more data. I'm going to get some purchase data. I'm going to check that purchase data if they have had 10 recent purchases. I'm going to get some more information about the user, so I have their email address, then I can send them an email to say that they get some loyalty benefit for making so many purchases. We really appreciate you as a customer. This can all be done locally inside of Stripe, inside of the system of record, which means that you can have this very complex interaction inside that source of truth, inside of that originating system, and not have to rely on the network at all. So the advantages here, the code executes locally, right? It's as if it were your own function call. Instead, the logic is being provided by a customer. There's no network involved. You can do these super complex interactions, and the interaction can happen in microseconds. These are local function calls. It's not a network. And the data remains inside of your infrastructure. You know that you're in control of that data. You know it's not being exfiltrated, to some third party where you no longer have any idea of how it's being used. And the benefit too is like Acme Corp in this case, they didn't have to spin up any infrastructure. They get to push their code, they can bring their decisions to the platform where it makes sense to run, and they don't need to have any additional servers handling webhooks, making API connections and such. So the key difference here that I want to really focus on is in a 1.0 world, you're sending your data to be processed by customer decisions. On this side is the source system sending data back and forth so that the customer can make decisions about what to do. And in a 2.0 world, your customers are actually sending you their decisions to you to run locally on your data inside your platform. That's a pretty key difference here. But doesn't this mean that they're like running user code? And I think any sufficiently senior software engineer has probably run into this desire over points in their career and been slapped in the wrist or reminded that, like, hey, you can't just run or eval user code. You can't just load anything untrusted and run it dynamically. And that's where the unlock of WebAssembly comes in. And so WASM, just to kind of spend a very brief moment, is the technology that underpins what XTP is providing. And very quick background, it's a safe sandbox execution. It's completely isolated in terms of its memory access to the host system. It was built and designed for the most hostile environment in the world, the web browser, but we run it everywhere now. It's no longer restricted to just the browser. It runs in the server, it runs in the database, it runs in your edge devices and IoT, because WASM is a portable bytecode format. And it's completely independent of the system architecture. So it doesn't matter if you're running the WASM on an x86 rack in a data center, or if you're running it on your MIPS device, that's handling your Wi-Fi inside your home. It will run independent of that system architecture. You don't need to recompile. The plugin will work in any software. And it's a compilation target. So dozens of programming languages already will target WebAssembly and compile straight down to it. So who's using this? Like, why is this important to know, and who's kind of taking advantage of this? There are some like incredible innovators in this space, and we really appreciate their kind of frontier adoption of WebAssembly. So to kind of give you a few examples, Shopify, the leading e-commerce provider, runs a WebAssembly-based app ecosystem called Shopify Functions, and they allow their third-party developers to actually inject code directly into the little line of logic inside of Shopify. So if you want to build an app in Shopify now, you're actually compiling code to WebAssembly and running it directly inside Shopify. Red Panda is a Kafka-compliant database streaming technology. They have a broker that runs a WebAssembly runtime inside that allows you to do transformations on data as it passes through the database. No longer do you have to connect to the database, take data out, make a transformation inside some subsystem, push the data back in, and let it flow through the database. It all happens directly inline inside of Red Panda. And then lastly, Istio and Envoy, a very popular cloud kind of proxy technology. Within Istio and Envoy, there is a WebAssembly sandbox that will let you filter traffic as it enters and moves throughout your cloud. So these are just 3 examples. There's plenty more, but our hats are off to these folks who are doing a really great job. You might not have all the resources to work like Shopify or to have a huge open source community building everything in like Envoy and Istio. And that's where XTP comes in. We want to help you take advantage of this new technology and bring it into your application infrastructure so that you too can have just as flexible and extensible software like all of these folks. So XTP, in a nutshell, provides streamlined guest management. If you want to provide authorized access to a third party to push code that gets run inside your application, we handle that for you. We have a great developer experience platform where we can generate documentation, we generate plugin boilerplate, binding code, and more, leveraging our own schema, which is a very familiar definition language for anybody who's used OpenAPI, and Ben will talk more about that in the demo. We have a full testing and simulation environment. So we actually allow you to create a mock digital twin, in effect, of your application inside of XTP so that you can test and simulate these plugins that run without ever having to load them inside your own application and prove that they're going to work, have the kind of assurance that you'd expect before you run the code yourself. And then last but not least, a code hosting platform so that you can store and retrieve plugins from XTP without having to spin up your own object storage or infrastructure to maintain that code. So hope I did that in enough time. Cool, we're just at 15 minutes. I'm on time. Ben, it's your turn, man. You want to take it away and start this demo?
Sure. Yeah, let me share my screen. I'm going to share my whole screen, which is not a good idea, but it's no better way to do it, I think. You can see my GitHub here.
Yes.
Okay, great. So yeah, let's get started. So for the demo today, I decided I would take us through something we created recently. And what this is it's kind of like a really simplified onboarding exercise. So what we've done is we've created this sort of fake application with a feature. And the goal of this exercise, we just kind of walk you through step by step how to add XTP to it and how to extend this feature and create a plugin system. And we're not going to walk through it completely step by step. I'm just going to kind of show you the main highlight points and show you what it takes to build an XTP integration, how easy it is, how it works, all that kind of stuff. So before we jump into showing what the application is, I just want to explain the point of this onboarding exercise. We have to kind of take on this role-playing exercise, right? So in this scenario, we are this multi-tenant chat application. We're similar to Slack, but our name is Yak. So we're the Yak developers. We own this application. Yak has this built-in / command feature. And this is, it works similar to how Slack works. You can do a / and run a command. And this has been successful, but it's all these built-in commands, right? And we want to give our customers the ability to write their own commands. So we're going to be using XTP to do that. I'm going to show you exactly what changes we need to make and how easy it is. So first thing we should do is just go look at the app. In this exercise, you run this locally. I just went ahead and pushed this up to the internet. But when you log in, you're logged in as one of your customers. So we're, logged in as Acme Inc., the sort of fake company / customer. We're logged into their instance here. And when you're logged in, it's just me and a bot. And I can talk in this thing, but the bot doesn't respond unless you give it a / command. So we'll give it a / command. And you'll see when we hit /, it'll show our built-in commands that we have. And we just have one here called count vowels, which basically you put in some input and it will count the vowels in that input. Super useful, really helpful. Steve's always asking for those count vowel reports at the end of the week. And it's really easy to just use this command. But the thing is Acme is growing. We have a lot of different responsibilities and we want to be able to write our own commands, right? Yak can't provide every possible solution that Acme wants to provide for their users. So we're going to use XTP to basically create this plugin system. So first thing we need to do is let's go look at the actual code of Yak. And we took the command handling stuff and just sort of moved it out into this file here, commands.js. And here's our count vowels command. And you'll see it's just a function that takes a message and then counts the vowels in the body and then returns a bot message with that count. So this is kind of our built-in command. And you'll see each message is one of these message types, which is just a JavaScript object. It has a body, a type, and nick. So it just takes a message and returns a message. Very simple. There's 2 points in which like the application, the server uses this commands module. One function is get commands, and this powers that drop down. So when we hit slash, it's gonna return the list of commands, which right now we just have count vowels. And the other one is the command handler, which is the thing where when a message starts with a slash, this thing is going to get called, and we're going to see, hey, is there a built-in command for this? We're going to respond with it if there is, and if not, we're going to respond with the generic unknown command. So this is roughly how the code works. When you're building a plugin system, typically what you want to do is you want to just like carve out or identify the interface of your plugin system that you want people to extend. So usually there's already naturally an interface in your application for the features that you built. So in our scenario, the interface is clear, right? It's like a slash command is simply a function that takes a message and returns a message. And we know what a message looks like. So with this information, we can now move on to the next step, which is create an extension point. And we do that in the XTP dashboard. You can do it through the API as well. We're going to open up the XTP dashboard. And to create an extension point, we just need a name and a schema. And the schema is like the interface. It's a language agnostic way to describe the interface. And essentially what we're saying is we have this place in our code called a slash command that we're going to let our customers sort of take control over and run their own code. So the schema, I'm not going to go too much into detail about how it works, but if you've seen Open API before, you probably are already understanding what this says. But just to give you a really quick highlight of like the key points, what we're saying is this interface, we expect our plugin developers to create a handle message function that gets called when a message is sent to this plugin. And that function takes a message and returns a message. And then we're going to tell XTP what that message is. It's this object. We can pretty much just copy paste or, generate from our actual types in our code and just tell XTP like what this is. And from this document, basically we need you to just kind of, you can put as little or as much information in as you want, but we want you to put as much information in as possible because this becomes the source of truth for all of your bindings generation, all of your documentation generation, all your validation. Everything is driven from this one sort of document. So the more that you can put here, the more that we can, the more value we can provide you later down the line. So I've already created this extension point, so I'll just move on from here. But once we create the extension point, the next step is to put this in XTP. So what we need to do that is XTP is generally just a library. And so because we have a JavaScript application, all we really need to do is install an npm library. And this is our XTP SDK for JavaScript. And what this SDK is, so what this SDK is it's just a JavaScript library that can talk to our API, and it can fetch and run plugins. So it probably looks pretty similar to like any other SDK you've ever used. You need to pass it a token, some kind of secret, and some sort of identifier for your application. And yeah, we create an XTP client here, and that's just sort of step one. Step two, we're going to go into that place where we are, listing the available commands, and now we need to actually show the user commands that they may have installed. So we're just kind of extending that object. We're just returning that list of count vowels before that one object, and now we're just going to extend it with the commands that are installed in our instance. And the last thing we need to do is just, go to that point where we're running the command and instead call XTP to run the command. So what that looks like is you can find your extension point by name. So we have the slash command. We just get it right off of our client. And then we can grab the function that the plugin developer implemented. So in this case, it's this handle message function. And basically what comes out is a JavaScript function. And the way this works is, again, this is WebAssembly. So this function could be in any language. It doesn't really matter. But at this point, we basically reify that function into a JavaScript function. So from your application's sort of perspective, it's just a JavaScript function. And it's there's no other infrastructure you need to install. There's no other network. You just basically pass it a message and you get back a message, and it's immediate. And this is all you really need for this application. Like all we really need is these two things, and we now can invite people to push code in, and we can run it. So that's kind of takes us to the last step here, which is inviting guests, right? So the idea of a guest. So we're a multi-tenant application, and we want to provide the users a way to authenticate and identify themselves in the system. So we have this ability to invite a guest. We can do this through the UI or through the API. And I've already invited Acme as a guest. And you're also implicitly your own guest in the system. But essentially, all a guest is, it's the authentication to basically create and push out plugins. And also you provide this like external identifier. So typically this would be, some sort of database session ID or some sort of user ID that you have for your customer that you have on hand that you can use to say, when I'm about to run this code, I'm going to give you this guest key, and that's going to tell me which one of my customers I'm acting as right now. So I've already went ahead and invited a guest. I invited Steve. Steve's going to play the role of like an Acme developer. So I've already invited him, and I'm going to sort of switch over to him, and he's going to show you what it takes to push the first plugin.
Thank you, Ben. Let me just share my screen here. The screen juggling is the fun part of this. So off camera, I went ahead and have accepted Ben's invitation, which allows me to access a slice of the view of the host application Yak that we've been talking about, our chat app, and to see the extension points, which I have access to. And so like Ben created that / command, I can view the schema and use this for some helpful reference information. But I don't really need to, because one of the beautiful elements of using the XTP schema is that I have just an incredible out-of-the-box developer experience. And I'm going to demonstrate part of that where, because I'm already logged in using the XTP CLI, I can initialize a plugin and run it. So my init command is going to give me access to the extension point, which I can push a plugin to. I'm going to choose the language option. Currently, we support Go and TypeScript. We also support every language that XTism PDKs have access to. More are coming in terms of the XTP kind of code gen pipelines. I'm going to show this in Go. We're going to create a plugin called Face, and it's going to generate me some code here. And I'm going to take a look at the code. It reflects like exactly the interface that Ben showed you in the schema. And that happens to be a function called handle message that takes an input of a message and returns the output of a message. And you can see I've got all the kind of nice type information and editor autocomplete, which is powered entirely by that XTP schema. I'm going to fill in this function with some code that I already happen to have written just to save us all some time here, but I'm going to walk through it just really briefly. My handle message function for my user, which will be pushed up into the Yak app, is going to be accessed at /face. The name of my plugin is also the name of the command. And it's going to take some input data, which is going to generate an image of a face. And by default, I'm going to use this API to load this image that gets randomly generated. But before I do this, I'm going to do something a little bit tricky. I'm going to do something that maybe a bad actor would try to do, to try to intentionally break Yak. And we want to prevent this from happening. So instead of providing a URL here, I'm going to put just some random characters, and I'm going to build this plugin. And oops, got to change it to the directory. And we're going to see that the plugin like builds fine, right? This is WebAssembly. It's all good. This would run, and you would maybe not catch that this is actually a problem. It's not going to actually load an image. But before I try to push this, you're going to notice that a test runs on the XTP platform. So I'm now trying to push this plugin up to XTP. It's going to be processed. I'm going to check that it's the right kind of format, that it's got the right interface. And then I've behind the scenes also added a custom simulation. And we can see that this simulation, which expects the plugin to meet the runtime criteria, failed. So we did not push this plugin into XTP. It has identified that the image's source does not have a valid attribute. And that is up to the host to enforce and say, hey, you know what? We can write a test that runs automatically as plugins are pushed to XTP that mimics the interface that our app has with the guest. And so because we were able to stop this, the plugin didn't get pushed. I'm going to fix it now and change this to be a proper source attribute in this image tag. And I'm going to build it again, and I'm going to push it again. And we should see a successful report about the validation this time, which will land the plugin inside of the XTP registry, make it available for Yak to load it. And I will let Ben take back over the screen to exercise that plugin and show you what it looks like when it's running. And Ben is muted.
Sorry, you can see my screen again?
Well, you can.
Okay, great. Yeah, so you just pushed up a face plugin, and you'll see we haven't really changed the application. We haven't deployed it or anything. But when I hit / here, face should pop up. So how does that work again? Do I just do face?
You can type some input to create a seed, or you can just YOLO it, and some random data will be used.
Okay, I'll just say face hello, and yeah, it works. So we have a face.
Look at that.
Cool. Awesome. So that's obviously very helpful.
Behind the scenes,
yeah,
the team has also prepared some plugins, and they'll be pushing theirs up. So momentarily, we should see some additional.
Oh yeah, let's wait a second for that. Yeah. So one of the things I did want to point out was so the first time you run a plugin, right? It's like it's going to go grab it, but the next time you run it, basically the plugin's already loaded. It's super fast. And I wanted to point out that, like, again, there's no network. WebAssembly can be compiled right at runtime. And it's very close to native speed, or it can be very close to native speed. So this is really just something you kind of can't do with any reliability with a sort of network-based system. I wanted to show one other thing. So I was going to go ahead and push a command as well. So I wanted to show what it looks like for TypeScript and also show kind of a different feature. So what I did was I made this like Spotify plugin. And you'll see I generated this the same way that Steve did. But we have first class support right now for TypeScript bindings. So you'll see it's really kind of a similar thing. It'll generate a stub for us with a message in and a message out, and all the helpful documentation we need and all the enums we need. And all this does is it basically just searches Spotify for the input. And if it finds a track, it'll just show it embedded. So an interesting thing about this is this actually makes an HTTP call. And it's important to note that, like, by default, WebAssembly modules, they can't, and plugins also, they can't like access any system resources. All they can really do is compute, right? So what I went and did is basically for this plugin, I'm allowing it to talk to the domain api.spotify.com, right? So it's actually able to just this one instance talk to that one endpoint. So you're as a application, as a host, you're able to strictly control what sort of resources, what sort of memory can be used, what sort of compute can be used by these different plugins. So let me go ahead and try and push this, and hopefully this works. And building it and pushing it. and it's going to go through all of our tests, and it should pop up. Sorry, it's actually my fault. It's a UI bug, of course. So we'll just search for something in Spotify, and hopefully it shows us something cool. Yeah. So this is a playable thing. I'm actually just going to mute it because I don't want Daddy Google to ban us. But yeah, so you can do all sorts of crazy stuff with plugins, but just know that by default they can't really do anything, right? So I had to explicitly, as Yak, say, hey, this plugin can talk to this one endpoint, but only this endpoint. So there are ways to kind of give you a little bit of level of control, but it could never talk to any other endpoint. It could never read from the file system or do any of those other kind of things. Yeah, so I think, yes, maybe some other people have pushed other plugins now. Yeah, there are other plugins. So we also had some people push some other plugins. So there's one, time zone. I actually don't know how this one works.
I'll paste something in the chat and you can copy it then if you want.
Okay, thanks. Yeah, sorry, I probably should have gotten this information before. But yeah, people are pushing up plugins, and we should be able to see. There's a dice. This looks pretty cool. That rolls a dice for you in case we need a random number. Reverse. I think that reverses the text, which can be useful. Sometimes you need to do that in your normal business operations. Yeah. So that's it. So want me to hand it back to you, Steve?
Yeah. Why don't we just jump back on screen and wrap it up here?
Sure.
Yeah, I think the point here, that we're trying to really make and hone in on is your customers are creative, capable people. They can do a lot, and you should let them do what they need to do to make your platform more usable, make your product more usable. And extensibility is really the way to do that. And the major key unlock here is that WebAssembly makes it safe to actually run your customer code. There are some additional restraints you want to put on that, and that's where XTP comes in. You don't need to be an expert in the technology. You don't need to invest tremendous amounts of budget in R&D, implementation time. As Ben showed, this took 20 lines of code using our SDK, and you have guest access, testing and simulations. You're running customer code inline. The opportunity to enrich your product and turn a product into a platform is now just an arm's distance away. So we're really excited to get this out there. We're excited to hear your feedback. We would love to talk to anybody who this was resonating with. So please go and join our waitlist at getxtp.com. And if you have any questions and would like to talk to the team about how to get this implemented, we are eager to hear from you and to discuss this. So thank you all for joining today. This was just a huge pleasure. We've been excited to do this for a long time. And yeah, please go check out getxtp.com, and we will be happy to be in touch. Ben, thanks so much for the demo. This is super cool. And we'll see you again next month for another version of our Dylibso Insider stream. So stay tuned. Take care.